Hi everybody and welcome to the cross-platform Revit, sharing code with plugins, Dynamo, and Forge. So the software industry has been changing a lot lately. New platforms are arising and some companies are porting their code to work in different environments. Huge investments are being made there. Microsoft, for instance, is porting their .NET framework to be a more modular, flexible, and platform-independent solution. Autodesk itself is porting their desktop apps to run in the cloud, what's called design automation on Forge. No installation is required. But how can we, as Revit developers, keep up with all these changes? How can we make sure that our code is ready for all these changes? My name is Thiago Almeida, and my career is a kind of a mix. I've started off as a product designer and then moved to civil engineering and software development. Currently, I'm the CTO of Shedmate, a startup that uses design automation for Revit to get people to design their famous Australian sheds, even via their mobile devices. And here with me today is my coworker Eduardo.
Hi everyone, my name is Eduardo Thiesen. I have a bachelor's degree in civil engineering and I've been working as a software developer for about 3 years now. I've worked primarily with the Revit API and I've been using design automation for Revit since its beta release.
Okay, so what we are going to talk about today is how do you create a application that can run in multi-platform. So you can write code for Revit and use it on the UI, use it as a command or an external application, but also port that same code and consume it in Dynamo, for instance, even on the web, run that, and then get the results back. So we have kind of a multi-platform Revit here. And this is our learning objectives. So we're gonna learn how to create structured and modular code using inversion of control principle. We also learn how to share data-specific code between different programming languages. We're gonna learn how to share non-specific code as well between different environments like desktop, cloud, and even front end. We're gonna learn how to share Revit-specific code between cross-Revit environments like add-ins, Dynamo, and design automation. So we have a lot to talk about today, and we are really excited to show it to you. So this is the start of the show. Introducing OnBox framework. OnBox is a free and open source framework to help you build modern cross-platform Revit applications in similar fashion that you have in Angular on in ASP.NET Core. So the biggest platforms out there for the web. The core design philosophies of the framework are modularity, testability, scalability, code reuse. So let's have a quick look on the framework itself. If you have a look on the class materials, you'll see that you can access the GitHub page. So that's my GitHub. And this is the landing page for the framework. So we've been working on this framework for kind of like more than 2 years now, but we actually have been ported the code itself to an actual framework and compiling the libraries for about 1 year. You can see some of the information about the framework here, as we talked about already. The documentation's in here, and I'll show you the documentation in a second there. We can see that the libraries that contains the frameworks are there. So we have all this as NuGet packages already for you to download and use. So it's all ready to use in your production environment. Okay, so let's have a quick look here on the documentation. So the documentation is still modest, but you can see here that we have some basic steps to get started. So we have some information about the dependencies. And by the way, we only use the dependencies that we absolutely need to. We don't want anyone to be relying on bloated code, and actually only real dependency, aside from Revit here, is the newtonsoft.json. The other one is just the compile time dependency, which is property change.40. So you can have a look on these links in there on the documentation if you like. So for the UI, we are using the what's called MVC design pattern. So MVC, it stands for Model View Controller. It's been used for a long time now. Simply, we just use MVC here because we found that is a good mix between the people that is using Windows Forms still or using WPF. So it's kind of the middle ground there. Next up, we have testability. So because we need to have the Revit context to interact with the specific applications or Revit applications, Revit elements, and things like that, you cannot test your code really easy in Revit, unfortunately. But hopefully the framework will have the tooling necessary for you to help you on that. When you have the code ready, you can use some of the frameworks for tests out there for Revit, specialized for Revit, like Revit test framework or the actual framework that comes with Dynamo. So versioning is an important thing here as well, because we don't want you to get on the DLL hell, especially if we're implementing a framework that we absolutely want people to use. And as more people are using it, we'll have different versions. Those versions will eventually collide. So what we've done to avoid that is we kind of approached a different versioning system, different than the semantic one that you find in other libraries and frameworks out there. So basically, we renamed the whole namespace when you're updating the framework. That way, you know for sure that your version that you're using is not colliding with the other versions. The cool thing about this approach is that different versions of the framework can be coexistent within a Revit session. So you don't have the problem of having other applications influenciating your command and crashing your commands in applications. All right. So with all of this introduction out of the way, let's get Eduardo to start talking about how you get started using the framework.
Thanks, Thiago. We're going to start by checking out the Getting Started section of the documentation. We're going to want to come here to the GitHub page, click on the Getting Started section, and the first thing you're going to have to do is download the Visual Studio templates by clicking this link right here. And then you'll download the zip files. And we're going to want to move them to the Documents and Visual Studio 2019 folder. Just copy and paste them to the Visual Studio templates folder. Now, if we come here to Visual Studio and click on Create a New Project, we're going to see, after selecting Revit in this drop-down menu here, that we have all the Unbox Framework project templates available for us. Now, we're going to come here and click on Unbox MVC app. Click on Next. And let's rename this to My First Revit app, Unbox app. And click Create. Now we have our project template over here, and it's already ready to start. So if you select your Revit version here and click on Start, And you're going to see we had some build errors here. And apparently this happens because of a bug with the Fonte property changed NuGet package. So to fix that, we're going to come here to build, click on clean solution, and you can see the clean was succeeded. Now come here to back to build and click on rebuild solution. And let's try this again. Clean again and rebuild. And now it's fixed. So once you have the NuGet packages all downloaded, and you shouldn't really have this problem anymore. We are now ready to click on start and have our application run through Revit. But first, let me just take a look at the properties of the project and come here on debug. And as you can see, the project is referencing this, which is the default installation for Revit. So if you, for some reason, decided to install Revit somewhere else, you're going to have to change this path to the path of your Revit installation. Let's also take a look at the packages that we have installed on this project. If you come here, right-click on the references and go to Manage NuGet Packages. You're going to see all the packages that we have installed right now. So we have the Fonte and newtonsoft.json, which already comes with Revit. So we pretty much only have our own packages installed. And now let's go ahead and start our application. Remember, you can change the Revit version on this drop-down menu. I only have the 2019 version installed, so I'll just keep it there. Click Start. Revit's gonna ask you to load the add-in. Click on Always Load. Now, if we just create a new project, I'm gonna select the default metric construction template. Now, as you can see, the plugin already has its own ribbon panel here, and it currently has 2 buttons. We also have a button here on the add-ins page, right here, Hello Framework. Now let's go ahead and click on the Hello WPF command, and it will just open a default WPF view. And that's it. You pretty much have your first on-box app up and running.
Thanks, Eduardo. And as you can see, it's pretty easy to start a project using the framework. But what is the purpose of this framework anyway? What it does and what the features that it gives to us? Let's set our keyboards and mouse aside for a moment so we can start and understand what is going on behind the scenes. And I promise you that we're going to go back to the actual code shortly, and you guys will continue on to participate on this hands-on lab. Okay, so it's designed to help you make your code flexible, modular, and scalable. And it uses similar techniques than we use in web frameworks for a long time now, like Angular, ASP.NET, Spring, and so on. Well, this will help you to write similar code as you write in Revit and on these applications as well. So you don't have those major workflow disruptions between one application and another, and you don't need to rewire your brain depending on the technology or on the platform that you're programming against. So what techniques are these? Well, there's many, but let's focus on what we consider to be the main one there. Let's talk about dependency injection. So dependency injection is a technique based on dependency inversion principle from solid design patterns. It abstracts away the creation of types from the places where these types will be consumed. That way, if you can modify what type will be created and how these types will be created without the need to refactor your whole code. This helps you to write cleaner and more loosely coupled code with a cleaner architecture. It would have been possible to explain dependency injection and inversion of control in depth on this lab. So if you're not familiar with these terms, please have a look on the web and get more familiarized with the terms. For now, we're just going to brush up through the concepts and how it applies to our framework. Let's say that we have a class in Revit API that will perform an operation on grids. We are calling this service grid service. And one of the methods on this class will be delete grids, which will delete all the grids from the entire project. To do that, this method will need to collect all grids from the entire project first. And to do this, it will use a second class called collector class. We can say that grid class has a dependency on collector class. And this is how the code would look like. On the delete grids method, inside of the grid service, we have instantiation of grid collector taking place. Then this grid collector, collects the grids from the project. Then it deletes the grids. Notice that we need to instantiate grid collector inside of delete grids. But what if we need to change the collector class and swap it to another one? Or change the behavior of collector class to take one or two arguments in the constructor? No biggie, right? Just add that argument there to the constructor. But what if we had a wall service or a floor service or 100 other services that uses that collector? This would be a pretty common situation in a real-world application. And it also becomes a maintenance nightmare. To solve that, we're going to use something called class decoupling. The first step is to move the creation of the collector to outside of the grid service. In this case, let's just assume that there's a field on this class that will hold an instance of that collector. Then we just consume it as usual. To get the reference on this instance, we're going to create a constructor to take that collector as an argument. Then we just store it locally. We can say that this class has no responsibility now to instantiate a collector. It will just consume it. So we can say that we invert the dependency on this class, or even better, the control of this class has been inverted. In fact, let's swap this collector type to an abstraction, like an interface of the collector. That way, if we need to create another type of collector and pass in for the grid service, we can, even without changing the grid service itself. This will make our application much more flexible, easy to maintain, and refactor. So how do you go about consuming this service? First, you initialize the collector. Then you pass it in as an argument to the grid service. And then you just call the method as usual. The cool thing about this method is that we now can have the ability to swap the collector to another collector. So as we said before, the grid service is unmodified. Alright, this is all good and dandy, but the grid class is a very simplistic class. Truth of the matter is, in the real world application, classes will have much more complex interaction than that. A dependent class would have several dependencies, and every dependency could have several dependencies under it. Let's have a look on this other example here. Imagine that we have a dependent class that will depend on dependency 1, 2, and 3. And dependencies 2 and 3 will also have a subdependency 1. Okay, now how to instantiate all these classes? Let's have a look on the code snippet. First, we instantiate the dependency class 1. Then, we need to instantiate 2 and 3. But to do that, we actually need to instantiate the subdependency 1 first. Then, instantiate the dependency class 2 and 3 that will take that subdependency as a parameter. Then, we can finally instantiate our main class. I'm putting it in multiple lines here just to make it a little bit more easy to read. We'll take all these arguments on the main dependent class. Wow, that was a lot of initialization taking place, huh? Looks like the inversion of control thing is just move the problem to another place instead of actually solving it. So, how can we solve all this? One way to avoid having all these instances being manually created is through the use of inversion of control containers, IOC for short. That way, we can simply request this container to resolve a dependency of a type, like this. This will return an instance of that class for you automatically. Yes, the container will automatically handle the instance for you. That instance could be a new instance or a cached one, depending on the context of that container. But we won't go into much detail on that right now. So here's the instantiation taking place before the usage of containers. And on the right, the same instantiation through the user of a container. Pretty impressive, huh? But hang on, how the container knows how to instantiate all these classes? How it knows when to keep a cached version or create a new one? Well, containers have 3 main lifecycle phases: register, resolve, and dispose. The registration is where you actually tell the container how to instantiate the types. The resolve is what you actually are seeing here on the screen. And the dispose, well, it's pretty self-explanatory, right? The good news here is that you don't need to worry too much about all these instantiations, registrations, and everything. Onbox will make it really easy for you. And since we're talking about that, let's talk about the project structure. And while we do that, we're going to see all these 3 phases that we talked about: registration, resolve, and dispose. Before we do that, let's talk about a traditional Revit application. We have 2 main components here: an application itself that will be responsible for creating the ribbon UI and initialize any application logic. This app class is often used to hold variables that needs to be kept throughout the life cycle of the application too. Then we have a set of commands that will execute some logic when the user clicks on it. Generally, here's where your add-ins will execute any type of logic that will perform the value for their customers. The thing with that approach is that any communication between the application and command are made in a manual way. You can store those variables and tell the command to go there and grab them. But there's no association between one and another, no information that associates the application and the command itself. Let's have a look on the code. And here we have a startup method that injects the UI control application class. And then we create the ribbon and the application logic there. Then we return. Okay, let's talk about the application inside of the framework. It will, by design, have a uniquely identifier container attached to it. This is the container that the application owns, and it is responsible for initializing and, as we say, register the dependencies on. Then we'll have a set of commands that will have a scoped version of the container attached to it. Remember, this is essentially a copy of that container on the application. But how they connect together? Well, we implement a command class that we simply reference the application as its parent, like this. Let's see how that's done in code. Okay, right off the bat, you can see here that we are inheriting from Revit app, not from external application. And here we are decorating the class with a container provider attribute. This is how we attach the container to the specific application. Then, here on the startup method, we can have a container injected for us. And now we can start registering the dependencies that we need. Any registration to the container itself will take place here. Now let's turn our attention to commands. This is how a command is implemented. Notice that we inherit from Revit app command, not external command. And then we have injected here a container resolver on the executed method. This is the only real difference from a regular Revit command. A container resolver, as the name suggests, is designed to resolve any dependencies that we need when running the business logic. And that's it. That's the skeleton of our framework. Now that we have that knowledge, let's see how this is implemented in our little application that we created with Eduardo before. Okay, back to Visual Studio. I'll change the targeted Revit version here. I'll go with 2021 for now. Then I'll double click app.cs class. This is essentially our initialization for the application itself. Here we are inheriting from Revit app, which is part of the framework itself. Revit app requires a container provider attribute that we're doing in here. I'll ignore the creation of the ribbon for now. Scroll down a bit, and here we can see that the framework injects the container for us. Then we can perform any registration logic. Notice that we also have the onShutdown method that injects the container too. And here we can clean up any related dependencies that we have. If we move back to the commands now, we can see here that the command inherits from Revit app command and then passes in as a type the actual application that is being used. The only difference here on the execute method is we have now a container resolver being injected for us. Then we can resolve any dependencies that we need and perform the business logic. And that's it. That's how the framework is structured in this basic way and how we can use the container on it. All right, so let's have a look on what we are building on this lab. Here I have Revit 2021 opened, and this is just a default new project. If I go to the Add-ins tab, notice that we have the grid generator button there. don't worry if you don't have that button just yet. We are building this on our class. Just to demonstrate what we are building, I'll click on that command. And here we have the grid generator window pop up. We have the ability to create horizontal as well as vertical grids. So I'll click that button a couple of times, and the vertical ones too. We can also change the offsets here and hit the create button. Notice that we just created a set of grids. It's a pretty simple application, but it's good enough to demonstrate what we are trying to accomplish. I'll also pull up Dynamo here. And I'll open up this grid generator 2 script there. Notice that since I have the automatically run here, I have some grids already generated. Here we have the ability to create vertical as well as horizontal grids too. We create 2 main nodes or custom nodes. The grid generator .create grid info, which has been used both on the horizontal and the vertical grids. Then we pipe these to a list, and then we finally input that in our custom node, which generates the Revit grids. So these 2 guys there, they're only metadata for the grids themselves. And this one here is the responsible for creating the actual grids on Revit. The cool thing about Dynamo is that we can slide these grids and they will update real time. The code that is running behind this Dynamo script here, it's exactly the same that is running on Revit or on our custom external application there. Closing down Revit completely, we're opening up Postman. Postman is an application that is used to send HTTP requests over the wire. We can send this HTTP request to a web server. That web server is something that I created especially for this lab. It will pick up that information and send to Design Automation for Revit and run our application. We are sending a grid collection which has vertical or horizontal and vertical grids. Let me pull this aside for a second. And we can see here that I have the drive for my application opened. And I'll rearrange those windows there and try to send that request. I'll hit send. And now we have a 200 OK response back. If I'll pull this over, Design Automation is running on the background. And we will be seeing here shortly the results in our server. Something's coming up. And we finally have the results back. I'll download that. And I'll open that in Revit 2021. All right, so now I have Revit opened on the background. And I'll just drag and drop that file there. Here you can see that we have some grids created, the ones that I asked on the HTTP request. So this file here was created, this Revit file was created completely remotely. We could have done that from a phone device or mobile device, a web front end, or anything like that. So we truly have a multi-platform Revit application here. Okay, so to get things started, I'll go to the unbox.gridgenerator.monolithic repository on GitHub. I'll click on clone and then copy the repository path. Then I'll launch Visual Studio here, click on clone repository, and paste that URL in. Next, I'll click clone, and then Visual Studio is cloning the repository. We can see here that all the classes has been cloned. Now I can open up the references and everything should be as warnings here. I'll change the version to Revit 2021. And as Eduardo told you guys, we can clean up the solution and try to build a couple of times. And one more time. And now that it's built, time to run the application. I'll go to the Start button here on Visual Studio, hit that, and then it will launch Revit. I'll click on Always Load, hit New. Any template will do. Hit OK. Just click on the Add-ins tab and Grid Generator there. Play around with the application and see if you can find any spots of improvements or even bugs. Now that we have played around with the application, we're going to use this project here on Visual Studio to copy some of these files to a brand new application that we're going to build from scratch. So I'll just set this instance of Visual Studio here aside for a second and launch a new one. Please do the same on your computer. Then you're going to click on Create a New Project. And then this time around, instead of choosing the Unbox MVC app, we're going to go with the Unbox app. This will represent only the UI application and the commands in Revit. I'll hit Next. And this I'll call AU 2020.grid generator .revit UI app. I'll delete the Revit UI app from the solution name because we're going to add some new projects here as well. Now I'm going to hit Create. Visual Studio will do its thing. Now I'll just change that from Revit 2019 to the version of Revit installed on my computer. Now I can clean up the solution, try to build it a couple of times, and in the first one it's already building succeeded. Now we are good to go. All right, so let's run the application and see what we got in Revit. I'll hit start. And Revit will launch. So I'll go to File, New, and then any template will do. So I'll just hit Create or OK there. And right off the bat, we can see here that we have a new tab with a panel and a command. Clicking on that command, we can see a Hello on-box framework in there. Gonna hit close, go to the add-ins tab, and we have a similar panel in there as well, which will do the same thing. So it's just a example of how you can do an entry point on your application. Switching back to Visual Studio here, I'm going to stop the debugging process. Double click on the app.cs, and here you can see that we have the onCreateRibbon method that will actually create the ribbon panel on the add-ins tab that we just saw, and also creates the ribbon tab in the panel. So in this example, we don't need a new tab. Just this panel here on the add-ins tab will do. So I'll just delete that for now. Here we can see that we are using the ribbon manager that is being injected by the framework for us. And we have the ability to create panel, right, that we just saw. And this will come by default with your name of your project. In this case, I'll just call this AU 2020 Lab. Just be careful to not name this the same one that you had on the grid generator, because Revit will throw an exception if trying to add two panels or two tabs with the same name. Then I'll call the add push button on the add-in panel manager, passing in a type of command that I want to run on this button and the availability of that button too. So this one is available on project. Notice that we have other options like available always, available on any document, on family, and on project. I'll go with available on project. And this is the actual name of the button and its image. Notice that we have this BR, which is break line. We can get the break line string, calling this ribbon panel or ribbon manager dot get line break. And then we can use that as a string template in our buttons. We also got this on-box logo here, which is the image that is being used to this button. And we can see that by going to the resources folder, expanding the ribbon images. And you can see here that we have on-box logo 16 and 32. This logo is used by convention. Since Revit uses two image sizes, we are just passing in the first part of the name of that by convention, and the framework is going to look for these two images in there. It's important that all these images, they are built as embedded resources. So if you want to add more images there to consume here, just change the build action to embedded resource. That's it. Then if you have a look on the command, it's asking for resolving a iMessage service. Then it shows that message to the user. For the container to know what type of iMessage service to use, we can go back here to the application, and we can see here that we add a iMessage service as a task message service which is the one that Revit can use. If we go to that class, you can see here that this is just a wrapper on top of the task dialog we have in Revit. Every time that we call error and pass it in the string to show, we're instantiating a new instance of task dialog and showing that message. Same goes for question. We set the title if you want, and also show a normal message, which is something that we are using in our application. Notice that this needs to implement the iMessage service because we wanted to add this as a singleton as a iMessage service. Because of this line, it's possible to ask the container to instantiate or to retrieve an instance of iMessage service for us. We can easily swap the task message service to any other type of service, even ones that do not use any UI at all. For instance, if you're running this on design automation for Revit, you don't want to have any dialogues or anything like that. So you need to go to a different approach and implement a different type of messaging service. All right, so now that we know how to create the ribbon UI, let's start doing some services. Here on the service folder, I'll add a new class. That's just a simple class, but I'll call this collector service. I'll hit add, and I'll make it public. I don't need a constructor, only the default would do for now. And I'll just create a new method here that will return a collection of element IDs. And I'll call it collect grids. I'll need a document or a Revit document for that. And I'll build a new filtered element collector, passing in that document, asking for a category of grids. I'll actually put that on a new line just to make things easier to read. And I'll ignore the types and send the element IDs and return those grids. Simple enough. So here we are basically creating a filtered element collector on this document, the active document at the moment, passing in the category as a grid category and ignoring the types and converting those to element IDs. We could do even better than that and just tell it to collect a specific category. So we can pass it in the category here. So I'll pass it in the built-in category and say category. And then I'll send that here on the Lambda or on the link to grab that category for us. So now this collect is a little bit more generic. Now we can test this out by going back to the app, and I'll create here a new push button using that same add-in panel manager. Add push button, and I'll create a collector task command that doesn't even exist at the moment. And I'll say that this will be available only on project. And I'll call this test collector. And I'll use the Autodesk logo button here or image there. Oops. Autodesk logo for that. So I'll create this collector task command now. So here on the commands folder, I'll expand here the onbox V8. So this is the folder structure that you installed. So I'll go to V8 here, and you can explore these templates here by going to the command availability and also the UI. So we have a bunch of predefined templates there for you. I'll use the add command, call this collector task command then, and just hit add. Alright, so this is already inheriting from the Revit app command, passing in the application, our application, as its owner. And here we have the container already injected for us. Just gonna save all this. And now I'll ask the container for a collector service. And I'll just say container.resolve and then collector service right there. And then I'll say var grids equals collector service. Oops, the instance, not the type. Collector service dot collect, and then passing in the document. So I'm gonna grab the document from the command data, application, UI document, and finally document, and then built-in category grids. I'll simplify this a little bit by just grabbing the document here from the command data, application, document, and it's much easier now to read if you just pass in this one right there. And then we're resolving the collector service here and grabbing the grids. So now we're gonna show that information to the user by going and just instantiating a message service or asking for the container a message service. So I'll go iMessage service and then message service dot show, and then we can say here we can actually say if grids count more than 1 or more than 0, or you can actually go in that and say any or else. And then if there's any grids in there, we can show a message saying this is the quantity, or there are grids count, pass it in as a interpolation there on your project. Or we can say message service dot show no grids found. Easy enough. So that's how we can instantiate the collector, use its functionality, and retrieve the results back using the iMessage service as well. This will work even though we haven't really specified the container to add a dependency or a actually registering the collector service here. This happens because the container is smart enough to instantiate any types that are concrete types. So if you're passing in a concrete type directly here, the container can instantiate that class for you. Let's see that in action. I'll start the application. Tell it to load. I'll create a new project. You know the drill by this point. Go to the add-ins. And you have here AU 2020 lab. And we have our new command in there. So I'm going to click on that. And you see no grids are found. I'll also create 1 or 2 grids in there. And hit test collector again. There are 3 grids on your project, so I missed the grids word in there. Oh, good. So we gonna shut down Revit now because our little command worked. Let me just go back here and say grids, or we can actually say something like that to avoid another if statement there. Okay, so let's create another service now. Create a new item there. And I'll call this Revit Grid Service. Turn that into public class. And the one method that I want here on this point is the ability to delete the grids, passing in a Revit document there. Okay, so to do this, I need to collect the grids and then delete them. But to have access to the collector, I need to create a constructor here. And on the constructor itself, I'll ask it to provide me a collector service. And I'll use the Visual Studio refactoring tool here to create and assign a field for me. So now I have access to that collector service. And I'll ask it to give me a grid ID list like this. And I'll use this collector service dot collect, then passing in the document and the grids category there. So now I have the list of grids, and I can see if my grid list has any element in there. I can run document.delete, passing in the grid ID list. And let me return this. And here I'll just return a new, let's say a new list of element ID. Which will be pretty much empty. So basically what happens here is I'll pass it in a document to delete the grids, and the collector will try to collect the grids from my project. And if there's any grids in there, we're just gonna go ahead and delete them. If it's not, we just return a empty list of element IDs. Now I can start using that code too. So if I go to the commands again, right click in there, new item, I'll go on box, V8, click in there, app command, delete grid test command, hit add, and here I'll ask the container to provide me with a Revit grid service, just like that, and I'll go container.resolve, then a Revit grid service like this. And then to use that, I'll need to start a new transaction. So I'll say transaction t equals new transaction, pass it in the document. I don't have the document there yet, but I'll just pass it in. I'll say lit grids, and then I'll say t.start and t.commit. Then here in the middle, I'll use the Revit grid service dot lit grids, pass it in the document again. And let's grab a variable here, which will be the document. So application, UI document, just like that. And looks like we are all good. We could here as well collect the elements that we returned and send a message to the user or something like that. But for the purpose of this tutorial, we're not going to do that. You know what? I forgot to add the command in the application. So let me go back to the application here. And we haven't really created a button there. So let me go back here. I always forget about this. So let's do the delete grid task command. I'll say available on, not on family, but on project. Come on, Visual Studio. All right, so you don't want it to, that's all right, that's fine. Let's say this will be delete br grids, and then I'll just use the Autodesk logo again, just for trying it out. Just run that. Go here, delete grids. So since I don't have any grids on my project, let's create some. Hit delete grids, and the grids are now gone. And you can see here that we ran the command. Just gonna go back there, create a few more grids, delete them again, and make sure if we don't have any grids, we don't run any command in there. We can, it could as well go there, and on our command, we could only initialize the transaction or collect the grids first and see if we have any to delete or something like that. But for the purpose of this this lab, we don't have to do that. So as you can see there, we created a new command or a new service, right? And this service uses the other service as an input, and we store that as a local variable, and we use it inside of a method, a specific method there. So with this technique, we can add more and more inputs in there, and we can actually use it as a container injector there. So if I go back to here, I can just ask this to resolve my dependencies, and then the container will do everything for me. Let's say, for instance, that we wanted to have a message service in here as well. So to add a message service, we can just say iMessage service, call it message service, and just assign it as a private field there. And in here, you can actually say message service, for instance, or not in here, but here on top, message service.show, and say deleting grids. Notice that I changed the Revit grid service here. I added new parameter here on the constructor, and I can compile this, and the build is succeeded. And I don't actually need to change anything else on my code because the container will instantiate that for me. So anywhere that I need to use this grid service here, in this case only in here, I don't need to change how this method is called or how this instance is created, because the container will do that for me. So I can continue on to refactor this code much more easily. While that technique worked really well, currently we don't have the ability to unit test this code because we're only relying on the concrete types here for the grid service and the collector service. So what we can do here instead is start using Visual Studio here to extract interfaces from this classes or these types. You can create it in a new file there. Hit OK. You can see here that we have now a iCollector service, and here's the inheritance there. And I'll do the same thing for the Revit grid service. Click in there, and then extract interface. Hit OK. Then we have that. Now, if you go to the delete grid tests, or sorry, let me go back to the Revit grid service, and instead of asking for a collector service as a concrete type, I'll actually ask for an abstraction of that. So now I'm referencing the interface of that collector service. Going back here to the grid test command, I'll also ask here for a interface in there as well. So we're referencing the interfaces. The rest of the code continues the same, but if I try to run this code right now, we're gonna have a break, or we're gonna have an exception on the container because it doesn't know how to instantiate a abstract class or abstract type. We're gonna need to go in here and add here the way that it needs to be resolved, or in other terms, we need to register those interfaces as concrete types in there. But before doing that, I'm gonna launch Revit again and show how this will break. Okay, so now I'm back in Revit. So go add-ins, and I'll hit delete grids, or let's create some grids first, and you see the command breaking in there. So let's see the exception happening. Right in there, you can see my Visual Studio already popped up, and you can see here that we got an exception saying key not found exception, and we're saying iGrid service not registered on onbox container. So Revit will pop up this exception. You can see the same thing in there. So here's the onbox container is trying to resolve that dependency, but it can't. The way to fix that is to actually go in here on the application, and then we can register container.add. I'll add as transient now, and you can read more about transient and other types of registrations afterwards, or in the documentation, for instance, you can find some information about that here as well. Collector service. Okay, so only by just doing that, you can start Revit again. You can go to the add-ins tab again, and let's create some grids. Here. And now this is popping up as we did before. Hit close, and then my grids are gone. All right, guys, so this is pretty much what you need to do on on-box framework. You add services and then you can resolve them and use them as the way you like. There's the optional phase of abstracting away the services as interfaces, but for most cases this is really important because you can unit test those classes or those services after. This is a similar workflow that we have in Angular or in ASP.NET, for instance. The code that we have so far references Revit API and Revit API UI assemblies. While this is fine for what we are doing here, a simple Revit application, it would be much nicer to have a separation of code here, like 3 or 4 assemblies, and we could reuse parts of these code to Dynamo and Revit Design Automation in the cloud. To start doing that, I'll create a new project on my solution. I'll select a on-box Revit DB, and I'll call this a u2020.gridgenerator.revitdb. As the name suggests, I'm not going to reference any Revit API UI on this code. Only the Revit API assembly. Just trying to build this one to see if my references are now resolved. And then I can start moving some of this code here to here. For instance, the services, they only reference the document, which lives inside of the Revit DB namespace. So I can easily just move them to here. I'll delete them here like this. Now my code here is break, and I'll add the reference to the other project. My Visual Studio just crashed on me there, so I'll just add a reference for here. Goes to solution, add the reference there, and we should be good to go. But instead, I'll actually move to another namespace there. I'll call this DB, or just get rid of this one here. And I'll do the same thing for the other ones as well. Just get rid of the inner namespace there. And this one is actually using, I moved that one, but this one should be actually back in my UI because this is a task dialog. So let me get it back there. Let me move that back in. Delete it from here. And this one, I'll call it Revit app.services like this. Let's see if my solution builds. Need to resolve some of these on as one. There, we don't actually need those, do we? No. Just gonna remove them. This one here. Using grid generator. Don't need that one there. Let's try to build my solution again. And yeah, all good. So my code will run as usual, but now I have a different assembly there that can be shared between different Revit code. And I'm using that assembly in here by registering my services the same way that I did before. So if I were to run this again, it will run in Revit as per usual. The other thing that I can do here is to add yet a new project in there, and I'll use a class library as .NET standard. Hit next, and I'll call this AU 2020 grid generator .core. Hit create. So in this project, we can start to create services and data models that doesn't really reference Revit at all. It's important to separate this core project because we can reuse this logic even without the Revit context. For instance, in our application, we're going to use a data model called grid info that will hold metadata of the created grids or the grids that will be created. So I'll create some properties here, like the name, another property that will hold the offset, and another one that will hold the total offset. Now we can share that data model with the UI app as well as the DB app. If we had more projects here, for instance, if we had a ASP.NET Core for the web, we can reference the same data model since it's just a .NET standard library. Now that we have this workflow in place, go to the repository linked on our class materials, grab the onbox.gridgenerator.modular repository, clone that, and on the source code, you can see here that we have the core application, we have the Revit DB application, we have Revit UI application, and we also have the web, Dynamo, and design automation application too. You can continue on exploring that, and you're going to see that some of this code, for instance, DB and core, is being shared throughout the other applications.
So if you're using this technique that Thiago mentioned of having the code separated into different chunks depending on the context, you might run into the issue of needing the same class on two different programming languages. So in our case, we have this Angular web front-end web application here and a C# shared library on the background. And in this case, we need to have these grid classes also on the Angular application. So to do that, we're going to run an extension, and you're going to want to come here to the extensions tab and click on manage extensions, and let's take a look at our installed extensions. And you can see we have this typewriter extension, and what it does is it's going to take all the classes according to this template, all the classes that are on this library, and recreate them in TypeScript on the Angular application. And it might seem unnecessary, and you might want to just recreate the classes manually, but for bigger applications where you have a lot of different classes, you really don't want to do that since it will become a nightmare really quickly. So for instance, on Shadmate, we have over 100 model classes and that need to be shared between applications. So every time you change one of them, you would have to go and find the correspondent TypeScript class and change it as well. So this really helps keeping the models consistent and avoiding a lot of unnecessary work. So let's take a look at it in action. I have edited these grid settings and the grid class, and now I'm gonna save the project, and you're gonna see it says rendering template down on the bottom, and in a couple of seconds you're gonna see the classes being generated on the TypeScript. And there you go. That's how you can easily set up different languages to work with each other.
All right, guys, this is what we have for today. And hopefully this is only the beginning of your multi-platform coding for Revit. If you want to check more about the framework itself, you can have a look on the articles linked here, the same ones that you're going to find on the class materials page. We have the complete API documentation there as well, linked for you. Source code is in there for you to clone and to check it out as well. We are preparing a lot of step-by-step video tutorials and guides, so definitely keep your eyes peeled for that on the documentation page.
Okay, guys, thank you very much for watching our presentation. And if you have any questions, feel free to leave them in the comments, and we will be monitoring them during the event. Bye.
See you guys later.